Oh, thank you. Wow, I didn't do anything yet. I should actually start by apologizing to you. You've come here to hear my colleague Jörg speaking. Jörg was unavoidably detained in Japan and couldn't make it here, so I'm covering for him. But what I lack in his professional polish, I will attempt to make up in enthusiasm. And I am pretty enthusiastic about Redis. Before I joined Mesosphere, I worked as a freelance sort of general web and app developer, and I used Redis a lot. And I think I threw every single anti-pattern in the book at Redis over a few years, and it never, ever let me down. So I'm pretty excited today to be talking to you about both Redis and DCOS, because they're two of my favorite technologies. So let's start with a cliche. I'm sure this is familiar to everybody. Mark Andreessen said some years ago now, laid out an argument that software was eating the world, that every company, whether or not they were a technology company now, must become a technology company in the future. And today, the world's largest bookseller and largest video service and largest music company are all technology companies. And there's some side effects of that, of this sort of burgeoning rush of technology. It's that there are now, I think I saw a study recently saying the average number of connected devices in a North US household is 13. Annual enterprise data growth is up 40% year on year. And that data is, last quadrant there is unstructured. Businesses and users and the apps that power their engagement have become increasingly connected. And there are IoT devices everywhere and carried on our persons. And vast quantities of data are generated by those. And that has implications on how we build software. Nearly all the companies we work with day to day are looking to build more apps quicker and engage customers better. They want to leverage the data they're collecting on user engagement and operational metrics, and they want to do it cost effectively. And delivering those services means modern enterprise apps. And that means new technologies. And that means new operating models. And that's challenging, so a lot of value can get left on the table. I saw a study recently by McKinsey that said that of the 30,000 sensors on an oil rig, less than 1% was providing operational value or insight. And they described this as data exhaust, which I thought was a particularly nice metaphor, like all of this data just unburned, getting pushed into the atmosphere, just waste. And the reason for that isn't that companies don't want to use that data, or they're not motivated to use that data, or that it's not valuable. It's that they haven't got the operational expertise. And they haven't got the DevOps process and culture. So what's been the answer to this? It's been to move to the cloud rather than running everything in-house. And that's great. The cloud's great. It provides the 3 points there: agility, elasticity, and scale. And it gives you the building blocks, things like continuous deployment, so your code is constantly being pushed out rather than doing the sort of traditional software development quarterly drop. And container orchestration, so you can run your business critical applications across your data center anywhere. And you can pick and choose from those with cloud services. You end up sort of buying in the expertise rather than having to have it in-house. But there's a cost to it, and that cost is lock-in. There was a cautionary tale recently out of Snap's IPO. Snap is the company behind Snapchat. They were losing, they had to disclose their risks, business risks, as part of the IPO. And they were losing $500 million a year, which is reasonable for a company in their stage. But 80% of that, $400 million a year, was their tie into the Google Cloud. Now, the Google Cloud is pretty cool, and it provides some very some amazing services, but when you are completely reliant on them, you are also very much at risk if they put their prices up or simply retire the thing you're working on with. So you have factors to consider. Where is your customer data and why? Is your customer data strategy sensible, or is it where it is because it was convenient to the developer team at the time? And is your systems architecture sensible, or is it just what you happen to be buying at the time? So let's think about the architecture of cloud services that you might try and run on DCOS, which is the platform that Mesosphere provides. Underpinning everything is Apache Mesos, which is a battle-tested framework originally out of Berkeley in heavy use at places like Twitter. On top of that is the components of DCOS that provide things like security and container orchestration and networking. And then on top of that come services like continuous deployment, analytics, and databases. And this is where we see Redis coming in. As what is described on that, it's rather small writing, I'm afraid, as a platform service. And on top of that sit the business applications that you were writing in the first place, that a few years ago were just running in your data center happily, one per box. Underneath it all, you can see we've put the three most popular cloud providers, Google Cloud, AWS, and Azure. But there's also one more, which is your private data center, because you might want to have some control over this. And you might want to run across multiple providers. You may want to keep your traditional data center, but you burst out to a cloud when necessary. DCOS gives you that ability because of Mesos. So you can think about your data center as a giant computer with applications that just get installed on it via the what we call the universe, which is kind of aspirational, but it's our software repository. So that's as much as I want to do about the sort of overall idea of DCOS and the motivation that's brought it to where it is now. But I did want to just share a couple of quotes with you. One is by Larry Rao from Verizon, he was talking about how he sees the future and how he has to plan for the future. Building for the coming IoT market, and if I build everything in a silo, I have no chance. With DCOS, I have a single contiguous cluster. Adam Mollenkopf from Esri, the GIS providers, we're running real-time analytics and visualization from connected sensors. Before DCOS, we had nowhere near the scale we have today. And now we're doing predictive GIS, which is pretty cool. So how does this all relate to Redis, besides Redis running on DCOS easily? Well, let's think a bit about what Redis Enterprise offers on top of Redis. Redis Enterprise provides a highly available, secure, and proxied Redis cluster. The idea is it feels like good old comfortable Redis to you, the developer under the hood, but these extra features are provided for you as part of the enterprise package, so you don't have to do those yourself. And this is an architecture diagram I borrowed from them, showing the proxies, the watchdog processes, a powerful distributed proxy configuration, and multiple container endpoints. A traditional distributed system, in fact. And these are the advantages they promise, which may sound a little familiar from our cloud data slide earlier. Scaling, availability, and cost, which is very similar to our agility, elasticity, and scale in the cloud. But what happens when you run Redis Enterprise on Mesosphere? We were pretty excited because we already have a Redis package for DCOS to partner with Redis and provide a Redis Enterprise package for DCOS, providing all of those advantages, but on top of the existing advantages of DCOS. So you can run your business workloads and your data streaming pipeline and processing framework on the same machines on which you run Redis Enterprise. We partnered to build the Redis Enterprise package with the DCOS SDK, which is new, relatively new to us. It allows you to build those data services that sit on top of DCOS very simply and with the power of the concepts of DCOS, such as services and short-running jobs. So I put a link up there because we're kind of proud of the SDK. And having your data services on DCOS provides some additional advantages. Provisioning is much easier, and you have things like blue-green deployments. So if you want to deploy a new version of your application, you can do that. You can wait for it to become healthy and drain traffic between the two using our advanced networking systems. You can resize instances. You could add instances to an existing cluster. And all of this sits underneath Redis Enterprise. So this is the sort of final architectural diagram. Enterprise on top of Enterprise DCOS, on top of the cloud provider of your choice. Would anyone like to see a daring live demo? Yay! Cool, just give me a sec to mirror my screen. Okay. So what we can see on the right here is the Mesa for DCOS UI. This is a freshly installed DCOS cluster. You can see there's nothing running on it at all. 0% allocation of the CPU, 0% memory, 0% disk. And I'd just like to demonstrate a simple Redis installation now. That is the wrong tab. I go into my universe packages. I search for Redis. There's Redis. And it's a one-click install. Done. So what did that actually do? Well, it's, again, pretty simple. This is regular vanilla Redis, by the way. If we pop over to the services, where there were no services running before, there's now one, which is in a deploying state. That's actually starting Redis in a container somewhere in my cluster. This is a configuration of three private and one public agent. So that's become healthy, and it's pretty boring to look at so far. We know it's there, we know it's running. We can find out more about where it's running by going and looking into seeing it's running on host 191. So let's deploy an application alongside that. I'm going to use the DCOS command line for that, so I'll blow that up a little bit. I'm going to do DCOS marathon. Marathon is the container orchestration system app add app1. And so that creates a deployment for me. You can see my CPU allocation jumped, and I should have one more service deploying in the services tabs down here. One currently idle, it should appear any moment. So let's have a look at what that application was. I spared you a little tiny bit of JSON configuration in there. This is a 10-line Python script, and it prints where it's running, and it's running on, and it also connects to a Redis instance, which is the one we just started, port 6379, prints whether it's connected and how many keys, and then it sleeps, and that's it, that's the whole task. So we can go and have a look in the, find the task, see it running there, it's running on host 70, so it's running on a different node from Redis itself. And if everything worked, we should see some logs now, DCOS, task log app1. Cool, yeah. It's running on 70, and there are 0 keys in Redis, which we know because we just established that. So far, so good. Let's start another app. This one is going to be called app2 because I'm kind of an inventive like that. And app2 also deployed and is running immediately. App2 is a Go application. It's a little bit more complicated, but you can still sort of get the gist of it. This also connects to Redis, and it prints ping, and in its response to a HTTP request, it will print out some HTML. So if I SSH into my leading node now, DCOS node SSH. Okay, so I now SSH'd with the CLI into the leading Mesos master. I can curl the service, the load balanced endpoint of app2. So although this was pretty simple, there's quite a lot of powerful tools in use here, and load balanced networking is one of them. If I click into the configuration, I should be able to see the load balanced service address of this app. It's DCOS 101 app2. So I'm going to curl it. Oh, I apparently copied a tab. Sorry about that. Convert them to spaces, I guess. OK. And hopefully you can see that reasonably well. That's just an HTML that came out in the curl response. That's kind of nice, but it's not the most impressive thing in the world. Let's make that publicly available, because at the moment this is all securely limited to my cluster. I can only see this because I'm authenticated with my credentials. So I'm going to pop back to the universe, to packages, and have a look at Marathon LB. This is Marathon Load Balancer. I'm going to install that, and I'll pop back to my dashboard for you. And we should see a task deploying. It's just staging right now. And this one is constrained to run on the public agent only. So if I nip over to my nodes, my public agent is this one. And sure enough, Marathon LB is running there, and it's healthy. So what did that actually do? Well, the external load balanced address of my entire cluster right now is here. It was not serving anything, but now it's serving something. And you can hit this from your mobile, by the way, if you want to. This is publicly available on the internet. So let's put a test value in here. We added key Redis and value conf. And over in my app 2, which was the serving process, I can go into the instance and have a look in the log. And we can see where that post request happened. And if I hit once more the task log for app 1, you can see the number of keys changed. So that's a pretty simple demo of the networking power of DCOS and how well it plays with Redis. There was very little typing there, very little configuration, and we automatically got 2 applications talking to each other across a cluster, running on different nodes, with load balancing, with a public, with good security, all done for us. So that's as far as the demo goes. Let me switch back to. And this is how you can get started if you'd like to do that. You can go straight to DCOS.io. You can come visit us at the Mesosphere booth. We're just around the corner outside. And we keep active Twitter presences up, both at DCOS, which is the open source project, and at Mesosphere, which is the company behind it and the company behind Enterprise Mesosphere. And that's what I've got for you today. But I'm very happy to take some questions. Oh, just one second, sorry. There's a microphone coming your way.
I saw you just created one node of the Redis. Is it as simple if you make it into a cluster? If you get 3 of them?
Yeah, so what we've got there is Redis running in a container on a node. And that is not ideal right now because, what I could do is scale that up. So actually, I'm gonna unmirror again and get the extend the demo a little bit since we've got time. And scaling this up across multiple clusters would be as simple as, across multiple nodes would be as simple as this. I could ask for 4 instances. And you can see that 2 of those have started on the same machine, and 2 of them are on separate machines. So that's as it's filled up its resources. But you're still going to have to do your own, and these will all be load balanced on that same address. But you're still going to have to do your own configuration and your own security and your own networking between those instances. And this is kind of what the power of the Redis Enterprise package, which we're announcing, is that this is done for you. You have the same container orchestration managing your Redis Enterprise instances as is managing all of the rest of your business critical applications and your other services. So if you were using Spark with Redis, for example, your Spark jobs could be running side by side with your Redis instances. But you'd still have all of the automatic failover and security and the proxy configuration that Redis Enterprise gives you.
Is there, so just to follow up on the Redis cluster question, is there a decently easy way to get control over these Redis instances, or do you literally just Redis CLI into them with that host address there?
Yeah, you can Redis CLI into them. One thing which we're playing around with is deploying a sort of sidecar process to each Redis. So you could use Commander or Redismin or whatever your preference is there. That's pretty easy to do. Did you have a specific use case in mind?
Well, mostly for the cluster setup.
For cluster setup, right. Yeah, what we try to do with all of our universe instances is provide a reasonably configured setup in the first place. So it would have its own service user. We have a concept of security service users, and it would have its own load balancing and internal DNS addresses all set up for you. So a lot of the administration wouldn't have to be beyond like the actual beyond the stuff you would naturally have to do with your applications should be done for you.
When you go to the universe and packages when you do installation, is there I know with some of the other ones you can actually customize installation of it. Is that something that you can do with the Redis one as well?
Oh yeah, absolutely. Let me just show you that as well. Yeah, the question was that there's an advanced installation configuration possibility with many DCRS services, and was this possible for Redis as well, which it absolutely is. There's an advanced installation. At the moment, it simply offers how many CPUs and how much memory you'd like to allocate to each process. You can do things like insist that one application, no more than one application per node runs. So if you have a 1,000 node data center, you don't end up with 4 Redis instances queued on one machine, for example. So these are all things that are possible. And you can also edit, because this is simply deployed on top of our existing container orchestration layer, Marathon, you can actually go in and edit this directly from the UI. So if you want to scale up the number of CPUs, you can do that. And if you want to mess around with the networking, service endpoint, for example, I could insist on a particular host port.
So in your little Go application and Python application, you had the hard-coded ports and network addresses. Is there any sort of like exposed discovery tool? Can you query for give me my Redis with this name kind of thing? Give me the port.
Yeah. So what you were seeing there, I didn't like to
style.
dive too much into the details of the networking there. But what you're actually seeing is a virtual manually assigned networking address. So that port isn't necessarily an actual port on a machine, and that host name doesn't necessarily resolve to anything, but it all works within our own internal DNS stack, which is how it's possible to balance loads with a single machine like that. It's all done in software. Cool. Well, it's been really, really nice talking to everyone today. Thank you so much for your time.